afternoon, everyone. I'm really glad to see you all here. I hope you enjoyed the first 2 days as much as we did. I'm here on the stage with my friends, Ignacy, who is engineering manager on Google Kubernetes Engine. My name is Jerzy Foryciarz. And we're going to talk and demo a lot of fancy stuff. But before we do, let's take a little survey. Can you please all stand up for just a little while? Excellent, thank you. All right, so those of you who use horizontal pod autoscaler on custom metrics, you may sit down. I see a few faces. All right, OK. Next question is harder. Those of you who never had problems figuring out the pod spec, you may sit down. OK, good, good. All right, those of you who use Node Auto Update in production, you may sit down. All right? Those of you who believe that you should all use Cluster Autoscaler in production, you may sit down. Thank you. OK, that was great. That was fun. Thank you very much. So here's the contract. In the next 45 to 50 minutes, we are going to tell you how to become a hero by setting up a pool of autoscaling workers based on a PubSub queue. And then we are going to tell you how to not to be defeated by a wrong pod spec using vertical pod autoscaler, who takes care of it for you. Then we'll explain how vertical pod autoscaler will never get defeated by missing resources in the cluster, because the cluster takes care of itself due to cluster autoscaler and node auto provisioning. And then at the end, you remember Man in Black with this little device? We'll tell you, well, you can really forget about the infrastructure part, because it just works. So you can focus on the top part. OK? So here's the deal. Let's get started. Before we get started, right, everybody is talking about autoscaling these days. This is an important thing. And you should expect for all of your workloads to scale, right? Scaling is different for your front ends, for your web page, for the mobile front ends. And it's different when you talk about databases or file systems. But because Kubernetes was built with scalability in place, and because GKE is the best hosted version of Kubernetes, you should have super high expectations about what's happening. All right, so before we go there, a quick recap. What's happening at Kubernetes? Kubernetes is very simple, right? In Kubernetes, you have a pod spec. In the pod spec, you're saying, well, here's my Docker container. I want this many replicas of it. And, well, this is the amount of resources I want to use, right? Once you have it, you give the config file to Kubernetes master. You put the container image to the repository. And then Kubernetes master is consulting a scheduler and saying, oh, dear scheduler, could you please tell me where is the best place I can deploy this very pod, right? So scheduler is looking at the lower layer on the picture, where all the nodes are located, and saying here, right? And then Kubernetes downloads the pod from the repository and deploys it on the cluster. And then it's maintaining it through its life, right? So whatever happens with the pod, it will get restarted by Kubernetes that is watching it, right? It's always going to be there for you. Now, as you saw on this picture, we are, in fact, talking about more than one layer, right? You have the infrastructure layer on the bottom, where your virtual machines or your physical machines are. We call them nodes in Kubernetes. And then you have the workload layer. And this is the fancy layer. This is the abstraction layer where everything is beautiful and you just deploy your pods. And we expect you to just have fun of deploying your pods without worrying about the lower part. So because of that, and because of these two layers, you in fact have also more than one dimension of autoscaling, right? So in the upper layer, well, you start from horizontal pod autoscaling, right? You have the pods, and in case of the workloads that you can load balance in any way, like your mobile front end or your website, well, if there is more traffic, you need more pods. If there is less traffic, you should need less pods, right? And Autoscaler does it for you. And this works well, but not always, right? Because in some cases, you actually need to change the pod requests. You may want to say, I want double the amount of processor or triple the amount of memory, right? And that's the vertical scaling of it. That's a totally different dimension. Well, and that was the workload layer, the fancy layer. And now, realistically, then you have this other layer, and it's different between the on-premises and the cloud. On-premises, well, you pretty much have what you have. So that's your sunk cost. And the best you can do is to use them all. Ideally, just use 100% of CPU utilization on them and be done, right? Nobody ever achieved that, but it's like, use them, right? In the cloud, you don't have to do that. In the cloud, in fact, you have the ability to request exactly what you need, and then use it only when you need it, right? And this goes a long way. Like, you may request specific types of machines that are having the amount of memory and the number of cores that exactly correspond to what you want to deploy on top of it. You may want to request something that is even more sophisticated, but because it has a graphics accelerator. All of that is possible in the cloud, not so much, and without any flexibility on premises. So now, well, on the infrastructure layer in the cloud, you also have abilities to scale, right? This goes roughly the same way, meaning, well, if there are more workloads deployed from the workload layer, then you're going to need more nodes in the infrastructure layer to handle it. So the idea here is to reactively, very quickly, get you to appropriate type of a node, right, and remove them as soon as they're not needed. And now, so this is something that we call a cluster autoscaler. So autoscaler number 3 in this story. And then there's one more piece. And this one more piece, I'm very proud, it's in alpha, and it's coming to beta hopefully later this summer. It's called node auto-provisioning. And it's getting a different type of nodes depending on what you need. And you don't need to really worry about it. So we are going to talk piece by piece about all of these 4 dimensions, giving you a great demos. My friend is resting here in the corner, but he'll be up to speed in a second. So, all right. So here in the story, we have 4 dimensions of autoscaling. HPA, as we call it, horizontal pod autoscaler, more pods based on the utilization matrix. Vertical pod autoscaler, different pod sizes, right amount. Cluster autoscaler, more nodes based on pending pods in the scheduler. And then node auto-provisioning, all the goodies there are, different node pools, and the overall scheduling optimizer. This is what we're going to talk about. So let's talk about horizontal pod autoscaling in practice. So this is an example of a workload that is load balanced. So imagine we have 4 pods on the left, and what you see on the right is their CPU utilization expressed in terms of how much the pod is using versus what was requested. Okay? So as you can see, these pods are running hot, right? But if you manage to add one more pod, then the load balancer that you're using can spread the workload across more pods, and through this, the average utilization will be lower, right? And the same story will happen if you go the other direction. Imagine you were at the stage like this. Well, all of the pods were running below 50% of CPU utilization. Now you may say, well, we're heating up the data center, right? Yeah, 50% of our cores are basically doing nothing, right? So in the ideal case, we would just remove one of these pods and get the load denser on the other 4. So pretty much this all comes to a target, right? You set a target and you say, I want my workload to run on average across all pods I deployed around something like this, which is maybe like 60%, I would say. And then Autoscaler is getting the workload to that state, right? It's adding more pods when needed. It's removing them where not needed, observing over all of the loads of your cluster as they are. So that was the situation where you have the state proportional to the number of requests. But it's not always the case. And that's why we have something that we call custom metrics. In the situation of custom metrics, you may extract any metrics from your system. And this can be number of requests per second. This can be latencies of your system. This can finally be something like backlog of tasks in the task queue, which we have here. Right? So imagine there's a very simple queue. We use PubSub queue because we are Google, but you may use any other queue. It can be RabbitMQ, it can be whatever, Zookeeper, right? And then you have producers that deliver a piece of data to be processed and register this fact in the queue as a message, right? And then you have workers that pick up this message and start to process it. And then at the end, you have Autoscaler. And what the Autoscaler is doing is making sure that there is enough workers to get this data processed in a timely manner. That's how it works, super powerful. There are tens and tens of customers that we talk to that just need a system like that in order to process their workloads in a like timely manner in a very controlled way. So let's get started. I'm going to invite Ignacy Kowalczyk to the stage to walk you through the first part. Right. So can switch to the other computer. Right.
Everyone, and thank you, Jerzy, for a great introduction to autoscaling in GKE. So it's going to be my pleasure today to demonstrate how all these dimensions of autoscaling actually work in GKE. I'm going to start with, in the first part of my demo, with setting up the horizontal pod autoscaler for the pool of workers that will be consuming tasks from a message queue. These are going to be 3 simple steps. First of all, we're going to set up the workers, the task queue. The second step will be configuring the autoscaler that, based on the size of the number of elements in the queue, will autoscale the workers. And finally, we'll add some tasks into the queue and just to see the system rolling. All right, but before I get started, let me show you the environment we are using here. So, so basically, what cluster I'm using. So as you can see, there's a quite funny name of the cluster, but it's actually a development cluster so that I can show you some of the cool features of VPA and cluster autoscaler that are not launched yet. All right, let's take a little bit closer look at the cluster. So I'm going to check what nodes do I have here. So my cluster is actually running 5 nodes, each of them being N1 started 1 VMs in GCE. Okay, so I've got my cluster. So the next thing is the workload. I've actually set up my worker pool before this presentation has started as well, and through a deployment controller. So the deployment is called worker. Now let's take a look at the definition of this deployment. So the important thing is we've got 2 replicas, so we start with 2 worker tasks. All these tasks will have the label appWorker assigned. And you may also notice that because finding the right pod spec is so difficult, I just didn't set any requests from my memory. So going back to the console. So next thing, once we have the workers, let's check out our message queue. So as Jerzy mentioned, we're using called PubSub. So we've got one topic defined, which the producers will be using to publish tasks into the message queue. And we have one subscription that is called worker subscription, that's letting the consumers consume messages from the worker task queue. Our setup is such that each worker task is consuming messages from a single subscription. So therefore, what we're modeling is effectively a task queue, where each task in the queue will be delivered to exactly one worker. All right, so now the next step, once we have worker, queue, now horizontal pod autoscaler. So let me create horizontal pod autoscaler. What's here? Am I in the right directory? Yes. All right, so let's take a look again at the definition of this horizontal pod autoscaler.
It hasn't started.
Sorry. Yeah, this is a live demo, you see. I didn't pray to demo guys that well, possibly.
Oh, yeah.
Thank you. All right, so back to the definition of our horizontal pod autoscaler. So the interesting bit here is that we are using number of pending messages in our queue as a scaling metric. This is an external metric. This is supported in the V2 version of V2 API of horizontal pod autoscaler. Now, the target average value, what does it mean? That means that we want to have, on average, 25 messages in our queue per every pod replica in our deployment. So roughly, it means we want one worker processing the tasks per every 25 tasks in the queue. And as you can see, we are also obviously pointing our horizontal pod autoscaler at the worker deployment down here. All right, so now let's take a closer look at this horizontal pod autoscaler using kubectl. So the horizontal pod autoscaler has been successfully created. The name of the HPA is QScaler. Now the interesting column that I want to drag your attention to is the targets column. So this is where actually the target metric is represented. So the value 0 means that currently we have zero messages in the queue for every worker in the in our deployment, while the target value is 25. The reason why horizontal pod autoscaler is not scaling down our deployment is that actually we have set up the minimum and maximum number of pod replicas for our deployment, and the minimum number is 2, so we are kind of staying with 2 replicas here. All right, with that we're moving to the third step, which is let's add some messages into the queue to see things rolling. So I have a little script that will be adding tasks, and I'm going to show you how this script actually looks like. Again, a super simple thing. This basically generates 100 messages into our worker tasks topic, and doing so with 10 parallel threads, 10 messages in each. So this seems to be pretty simple mechanism, but actually the cool thing is that it is a very powerful design pattern. In fact, last year on the Next 2017, we showcased together with Airbus their solution where they were processing satellite images exactly with this approach. So what they've been doing is they've been publishing the images to be transcoded into the message queue, and then they were running a horizontally scaled pool of workers that were processing these tasks. And obviously, horizontal pod autoscaler was meant to find a good trade-off between the performance of the system and the cost. So in the meantime, I hope my messages got added. OK. And then let's see what horizontal pod autoscaler has to say about it now. All right. So what we see is that the metric is still 0, which means our horizontal pod autoscaler did not pick up yet, did not pick up the new metric from the cloud PubSub quite yet. We can, OK, it's growing. It's 25 now. So it's picking up. But basically, the thing is that what is happening right now, horizontal pod autoscaling is getting new updates from Cloud PubSub, with the metric being number of messages in the queue. So in the meantime, I hope that our deployment has already been autoscaled. So, all right, still we have only 2. So let's take a look at horizontal pod autoscaler again. Still 25. Slow delivery of metrics. We have to wait a little bit. Maybe I can take some questions in the meantime.
Can you raise your terminal so we can see it better, please?
Clear. Well,
Sure. Yes, that was a good point. Is any better? Yes. Awesome. Still 25. All right. Any more questions then?
OK. So I propose that while we're waiting for this one, let's talk about what can go wrong with this story. Is that a good idea? And in the meantime, we'll see what happens.
Sure.
All right. So let's switch back to the slides for a second. So provided this is actually firing up the way it should, well, demo gods. We're at taste, so maybe that's why. Well, if this worked, it was all good, right? Now, could anything go wrong?
I got it.
OK. Back, please. Back to the demo slide.
Thank you. All right. So
can we get back to the demo screen?
Yeah. Thank you.
OK.
All right. So retrying, we got 50. So this is the value that I was expecting you to see, right? We generated 100 messages, and we have 2 workers. So the average per worker is 50, while the target was 25. So again, let's take a look at our deployment then. And the deployment is the controller that runs my worker tasks. And voila. So right now we have 4 worker tasks deployed.
Yeah, 4 workers.
So
all right,
horizontal pod autoscale works.
Very good.
Back to Jerzy.
Worked. Thank you. Yeah, get him a round of applause. All right, so back to the slides, please. So yes, besides demo gods, nothing else can go wrong, huh? Well, not quite. We've been actually serving you for a reason, right? Well, realistically, how many of you run very detailed performance tests every time you deploy a new deployment? OK, 1, 2, 3. OK. And how many deployments do you typically do per day in Kubernetes? Well, OK. I'm assuming a lot. And in that case, this may get problematic if all of a sudden the situation changes in your pod and you do not correct it in the pod spec. So imagine in this situation, we're obviously setting up for that to demonstrate. Imagine in this situation, we started to run out of memory because the very last build added just one more feature, and this one more feature is using far more memory than before. Nothing is wrong with it. It's just a mismatch between the kind of a virtual space, which is your container, which was requested at a certain size, and what you really need, right? So in that situation, you go out of memory. And if you go out of memory, what's going to happen? Your job is going to get evicted by Kubernetes, right? And then scheduler will see it. And because I promise that Kubernetes will always take care of your pods, they'll get recreated. And after a while, they'll get evicted, and so on, right? Well, there is another possibility. There is, in fact, a race condition because Unix is also very smart. So you may, in fact, get your application reset by Linux before it gets evicted. But in either case, you're going to get in this vicious cycle of not having a workload running. So with that in mind, we built vertical pod autoscaler. So vertical pod autoscaler is a piece of beauty. That's roughly this. It looks at your workload. The size here, whatever we have in the 95% and the remaining 5, this was your pod. Let's say this was your pod expressed in the CPU utilization. And now vertical pod autoscaler is saying, just request a bigger machine for that. So you get a bigger machine, and all of a sudden you're not running 90% of the utilization of that space. You're running 70. The word is saved. So now, how do we do this, right? We do it in a very simple way. Through three steps, right? The first one is vertical pod autoscaler is watching the utilization. Does it do it for every pod you have? No. You actually have to turn it on, and you have to tell us, or well, tell vertical pod autoscaler what is the label, right? What pods do you want to watch? Once you do this, vertical pod autoscaler is consulting the metrics server, and it's calculating the recommendation. And at minimum, it's just providing the recommendation. And then also, you can enable automatic update mode, and I'll talk about it in a second. You can, in fact, actuate, right? But at minimum, this was your pod spec. Well, assume for a while that you actually put a request for memory on CPU. And it was wrong, right, for some reason. So what vertical pod autoscaler is doing is consulting metrics server. It looks at the piece on the left, which is your spec, and on the right, it's outputting a very simple recommendation. And this recommendation is in the middle. It says target, and it says, well, CPU, 2 cores, memory, a certain amount, right? And then it's also providing a range, and the range is for the updater to either take action or not take action. If you're not outside of the range, there is probably no reason for you to update, even if the target is somewhere in between. So that's how it works, right? So now we have 2 modes of update, if you choose to use it, right? One is only happening at the time of creating of the new pod. So whenever a new pod gets created, vertical pod autoscaler is reading what's in the pod spec, and is also comparing it with the recommendation. And if that's wrong, or if there is a mismatch outside of the saved range, then it applies correction. So in fact, the pod that's going to get deployed has a correct request. It doesn't mean that the pod spec was corrected. It's just, well, vertical pod autoscaler knows better and does it right. And then there is a second mode that we call full auto, that we, by the way, going to use here in a second, that does it also for all running pods. Right? In fact, it's observing the pod disruption budget. It is taking pods one by one, draining them, and recreating or forcing to get recreated so that they can just get adjusted. So that's it. And you may ask, I probably already spoiled it, but you may ask, will it pray together? So the answer is yes. And the answer is also, well, however, don't try it with the horizontal pod autoscaling running on CPU utilization, because this is the same metrics. It's not working quite yet. So on everything else, we promise it's working. And with this, back to Ignacy to demonstrate.
Thank you, Jerzy. All right, so in this part of the demo, I'm going to use vertical pod autoscaler. And as you remember, I was quite naive. I didn't set any memory requests for my application. And this makes me a little bit anxious. You know, I deployed it, and I kind of hope it runs. So I'll investigate the memory consumption of my application, and then I'll use vertical pod autoscaler to actually check whether I was right or whether the system is, running well. And then finally, I'm actually going to be convinced by the VPA recommendations, and I will turn on the automated actuation of vertical pod autoscaler recommendation. OK, so let's go to see what's happening in production. So I'm going to Stackdriver, and I have a little dashboard here, which presents me the memory consumption of my worker tasks deployment. Doesn't look good, really. So what is happening here? All these worker tasks are basically growing the memory consumption quite fast up to some point, and then they are kind of disappearing. So, so this is worrying me. So I'm going to take a look at my pods. So let's go use kubectl again. Well, so yes, I've got couple of them running, but then I have also a bunch of them evicted. So, so indeed, like something's killing my pods. I've seen them growing to like roughly around like 2.5 gigs of memory consumption, as far as I remember from the Stackdriver dashboard. So I'm going to check my nodes, how much memory actually the nodes have. So the reason is I'm checking it is that if I don't set memory requests, I'm pretty much free to use most of the available memory or resources on the nodes. Most of it. Kubernetes will take care that there is some extra margin. All right, so I have this little command line that I'm not going to be typing here, which basically, using kubectl, I'm enumerating my nodes again, but this time I also want to check what's the amount of allocatable memory on these nodes. All right, so they have 2.7 gigs of RAM. These N1 standard 1 VMs have 2.7 gigs of allocatable memory to user pods. So this is close to what I was observing on a Stackdriver. OK, so I have my suspicion already that basically my pods need more memory. So with that, let's try to consult vertical pod autoscaler. So right now I'm creating a vertical pod autoscaler. Again. All right, and it's been created. Now, let me switch to presentation to show you in bigger letters what's being done. So I have created a vertical pod autoscaler, and the interesting bits of these configurations are, first of all, matching by labels. So vertical pod autoscaler is different than horizontal pod autoscaler. It doesn't point, you don't point VPA at specific controllers such as deployment or replica set. Instead, it's a little bit more flexible, and you can select specific pods that you want the VPA to generate recommendation for through a label query. In this case, it's AppWorker. Now, the next important piece of configuration here is the update policy. So in this case, I set the update mode to off because all I want to know is I want to see VPA's recommendations. And well, I'm hoping that this will give me some more clues about what's going on in the system. As a reminder, we can also set up the update mode to auto. So in which case, the vertical pod autoscaler would do the rolling update of all my pods that are matching the label query and recreating them, basically killing them and letting them be scheduled again with the new resource requests. The reason is that currently in Kubernetes there is no functionality, there's no capability of adjusting the resource requests and limits for running pods. So you basically have to kill them and let them be rescheduled again by the scheduler with the new requests. All right, so in the meantime, let's see if our VPA has generated any good recommendations for us. All right, it did actually. So, so there is this in VPA resource, which is custom resource definition. We've got this recommendation section where we see that our VPA says, these worker tasks should be probably running at a target of 3.5 gigs of RAM memory request. So this is totally not something that my infrastructure is prepared for. My nodes were 2.6 gigs. So I'm going to be very, very naive now. I don't want to deal with infrastructure. I just want to actuate vertical pod autoscaler's decision. So what I'm going to do is I'm going to edit this VPA. And I'm going to change only one parameter, which is the update mode. So I'm changing to auto. Boom. And let's see what will happen. In the meantime, I'm handing over to Jerzy.
All right. So let's go back to slides. So now we're going to let the magic happen. In the meantime, let's talk about the proper magic. So in this section, we're going to talk about the cluster autoscaling. Obviously, you may expect what would happen in the normal situation, right? We would have the automation that we set up, the vertical pod autoscaler, to attempt killing the pods, and then we would attempt to recreate them with the different pod requests. The pod request would have been, the memory request would have been something around 3.2, I remember, right? So there would be pending. So we would literally kill our setup forever until somebody on the operator side, on your DevOps side would have realized, well, something is wrong. We cannot, this are not schedulable. So luckily, this is not how it's working. Well, we told you can forget about the infrastructure because the infrastructure is not forgetting about you. So this is exactly what's happening here, right? Cluster Autoscaler works through observing the pod requests, and based on these requests, making a decision or suggestion. So what you have here is a scheduler, right? The scheduler is in a normal situation, is looking at the pod requests, and it's placing a node, right? So if there is enough resources on a node, sorry, it's placing the pod. If there is enough resources on a node to deploy a pod, it's simply happening, right? But there may be a situation if there is not enough resources and you necessarily need to add one node, right? Like this. Well, there is an operation involved, right? What is this triggered by? This is triggered by the pending pods, nothing else, right? No utilization of any kind. The reaction is to, like, well, do I need more? But in some cases, you may be in a situation like this, which is even more annoying, because now you have too many nodes, it looks like, too many nodes. So in the ideal case, you would have done some kind of a defrag. Realistically, move one of the pods somewhere else so that you can remove the node and have a better utilization, a kind of better price to performance, as you may say. So this is all done by the Cluster Autoscaler. Cluster Autoscaler is doing literally two functions, right? And within each of those other three. So it watches the pending pods, first of all. It's just seeing what the scheduler would be seeing. And the pending pod means there is no space in the infrastructure for the pod to be scheduled, right? And then it simulates the scheduler by trying to look into what would have happened if I added one or two or three nodes, right? Would the deployment actually land, and would all of the pods be scheduled? If that's the case, then yes, Cluster Autoscaler triggers adding nodes. This is done by the part of the infrastructure, but the decision comes from the Cluster Autoscaler. Now, in the same time, it also watches the utilization, but it only watches it for the contraction of the cluster. So if any node is running below some set utilization, right now I believe we have it set to 50%. This is a trigger to look around this is a trigger for Cluster Autoscaler to look around and make some checks, right? What would have happened if we deleted that machine? Would all pods be rescheduled, or are there any system nodes running there, and that would be a big disruption, right? How would that play with the pod disruption budget? If it's possible, the decision comes to drain and delete the node, and then the scheduler is rescheduling the pods that were running there somewhere else. And through this, we have a better package system. So that was a very intro walkthrough, but the real Cluster Autoscaler looks something like that, right? Because in a cluster, you don't just have one type of nodes. Well, you could, but in most cases, you are deploying more than one type of the workload, more than one size of the pods. And it's very hard, unless you manage to deploy super big nodes that can accommodate everything, and you don't care for the empty space running on them. It's really super hard to optimize it with just one type of nodes. That's why the good practice that we were suggesting, and was there for like at least last year, maybe year and a half, was to use the node pools. Node pools are groups of identical nodes within the cluster, right? And like example like this one is like where you have some small nodes, some medium, and some big. And through this, the Cluster Autoscaler does a little bit different job, right? It it is monitoring the state of of the entire cluster, but it's also like whenever there is a pending pod, it's actually simulating the action of scheduler across all of the node pools. So it's like, what would that have been if we enlarge one of this, or the other one, or the other one, right? Well, this is a very simple example when you look at this single pod, right? But the pods are coming in all the time, and they are of different sizes. So realistically, there is lots of interesting combinatorics coming in. But thanks to this, you end up getting a very well and tight package cluster, right? So when the recommendation is placed, then the new node is added in the node pool of a choosing by the cluster autoscaler, and then the pod gets deployed. Now, there may be a situation similar to what we are setting our demo for, right? That despite the fact that we already have 3 types of node pools, 3 sizes of node pools, we now arrive with the pod that wouldn't fit to any of those. And before November, late November last year, that would be the moment where your system would get stuck, right? And it would have to wait for someone to notice there is a problem. Luckily, and this feature is now in alpha, and it's coming to beta later this summer, we have node auto-provisioning, which is like a consultant to the cluster autoscaler. So cluster autoscaler is not only running the simulation looking at all 3 of these node pools, but in fact it's consulting node auto-provisioning, saying what if there was another one? And if there was, what would be the size? And then at the end it decides there is a new node pool needed, it creates one, and then the pod gets deployed. Now, throughout this talk, we are telling you you can forget about node provisioning. So we're just explaining it to you so that you see how simple it is. But we leave you very little control. Just like you are switching a cluster autoscaler simply on and off, and you also get as a budget the minimum and the maximum of RAM of CPU, you just enable auto-provisioning. You don't need to worry about this layer. This layer just does the job for your higher layer. The higher layer is where your workload is, so you better know what's happening. This one is just adjusting to get you the best cost per performance. So, OK, so that's roughly it. So let me just walk you through what just happened, and then we're going to have a look into the demo again. So we had a horizontal pod autoscaler set to look at the pub sub queue as a parameter and autoscale so that for every 25 tasks, there was at least 1 worker deployed. We had a vertical pod autoscaler to watch, like after we enabled it into the auto mode, now it's watching if there is everything right with the requests of resources. And if not, we actually set it to auto. And as a result, whenever the request is wrong, it will get adjusted. And then on the infrastructure layer, the cluster autoscaler is observing the unscheduled pods, and it's actually consulting with the VPA so that this process doesn't happen prematurely in an awkward way. We don't want all of the pods to be killed first and then be pending later. So in fact, there is a loopback in which there is a translation of like, are these resources already prepared? And only if they are, the update is happening. And most of the real-life cases don't happen that drastically, right? They happen every once in a while. And then the node auto-provisioning is a consultant to the cluster autoscaler. It's making it more optimal. So as you can see, you have 4 autoscaler, but in fact, you have 1 system that is autoscaling all of it for you by having all 4 layers talking in unison. So that's what we have. And now, are we ready?
Yeah.
All right.
I will see. All right, thanks, Jerzy. So it's the final step of our demo. So we're gonna see what happened. So remember, like I was playing only with pod autoscalers, horizontal pod autoscaler and vertical pod autoscaler. And thankfully, I got my cluster set up with the smart node auto provisioning and cluster autoscaler enabled so that I did not care about my nodes at all. So now let's see what happened. So I'm going back to the console, and I have my little script that prints the pods, but also prints the, let me show it to you actually, but also prints the memory requests of those pods. So remember, like when I set up the pod spec for my deployment, the memory limits were empty. So let's see what they are now. So again, we have all these evicted pods that we had before, but we also have 4 running pods. And all these pods have actually the memory request set to 3.55 gigs, which was the recommendation of vertical pod autoscaler. So woohoo, this works. And they are running. You know, how is it possible, given that I had 5 nodes with 2.7 gigs each? So let's take a look at the nodes. I'm using my old script.
Before we go there, the historical data that we are showing there is like all of the failed nodes, but you look at the 4 that are running. We requested 4 to be running, and there are 4 running, right?
So indeed, we have our original 5 nodes in the default node pool, but we also have a new N1 standard 2 VMs in a new node pool created automatically by the node auto provisioner, and these guys are running 5 gigs of RAM each. And thanks to that, our worker task got scheduled. So it all works. Let me take a look at the stock driver chart, refresh it, and let's see if it looks better. Indeed, we see that the workers grew to bigger memory usage than before they were allowed to, and they are stabilizing. They are running at this level. So, wow.
All right. Okay, so let's go back to slides. This was great. So we hope you see that you can really forget about node provisioning. Well, in fact, you can set it up and almost observe that it occasionally goes to 0 or almost to 0 because there are still some system level pods that needs to be running, or that when you need it. So you may wonder, is that all? It should be all because we have 1 more minute and then questions. But, well, one more thing. Well, wouldn't it be great if that also worked with the graphics accelerators? Well, it does. With the new release that's coming to beta soon, node auto provisioning will be capable of scheduling your nodes with the graphics accelerators. So now imagine this very precious resource that is super expensive gets super automatically provisioned only when you need it. So you deploy your pod, your pod request just has 1 extra line, and it says what type of graphics card I want, right? And through the 4 steps that we were describing, in fact 3, because the horizontal pod autoscaler doesn't need to be part of it, you'll just get it. And then whenever it's not needed, it will be removed. But in fact, a while ago, you saw there were 4 new nodes, and there were also still all the old nodes. They're going to get removed. There is a cycle loop that's running every 10 minutes. So like in a while, like we've been speaking for a short time, in a while they'll get removed because this is how it works. All right. So
and you can also imagine the direction where it's going is that it doesn't have to be only size of the nodes and only GPUs, but like whatever infrastructure requirements of your workload. So you basically, the idea is you specify declaratively the requests, the requirements from the infrastructure in your pod specs or in your controllers. And that's it. You don't have to care about the infrastructure. The right infrastructure will be provisioned for you by node auto provisioning.
All right, so that's all. Now we have a couple of minutes for questions, and then we'll be outside to take more questions.